Hey folks, so this is example 5 from the section 1.2 notes. I asked you to think about this on your own, and I will go through my solution or my thought process here. So the question was, given a linear system, it has a 4x7 coefficient matrix with 4 pivots. So we asked the questions, the fundamental questions of linear algebra, right? Is this a consistent system? And if so, how many solutions are there? So again, this is the question, are there 0, 1, or infinite solutions for this system? So a couple of things that sort of stick out to me immediately. This is unlike any question we've done in class so far. There are no explicit values here. And somehow it's completely sort of like theoretical, and I'm given a coefficient matrix, so things are a little bit different. So I think the first thing that comes to my mind is sort of just almost sketching out what this question even looks like. So a 4x7 coefficient matrix would be the following. So remember, 4 by 7 means 4 down, 7 across. So I don't know the values, but I can sort of start sketching a picture. So a 4x7 matrix should look something like this. That's 4 by 4, 5, 6, 7. Okay. Now, what do I know? I know this is the coefficient matrix, and that's important, right? That this is only representing the left-hand side coefficients. And this does not have the right-hand side yet. Okay, so it's important to remember as we're solving. So what do I know? I know this has 4 pivots. And so let's take a minute to sort of think about different situations that can happen here. So if there are 4 pivots, then I mean, maybe one of them is here. So maybe one of them is here, here, and here. So that's one situation that's possible. I have 4 pivots, or, so I can play a little bit, right? So maybe I'll just do a little bit of playing. What else could happen? Maybe a pivot here, 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 here. That's possible. But what I'm seeing as I go through this is if I have 4 pivots, then I have to have 1 pivot per row, right? I mean, there's 4 rows and 4 pivots, there must be 1 pivot per row. And that's sort of an important observation that sort of comes immediately from just doing a couple examples. So each row must have a pivot. Okay, so why is this an important observation? Well, the reason this is an important observation is it already helps us answer that first question: is the system consistent? And the way I can figure this out is by, instead of thinking about this coefficient matrix, what if I were to add that right-hand side, that augmented matrix, right? So if I consider the augmented matrix, then, okay, it should look roughly the same, but I have 1 extra column. Okay, and now to make things a little bit easier for us to think about, I'm going to put that dotted line there to really emphasize that I have my left-hand side, which is the coefficient matrix, and the right-hand side, which is my right, like on the right? So if I were to copy and paste sort of the pivots I had for the last case above, down here, the observation that we can make is that because the coefficient matrix already has 4 pivots, there's no way for there to be a pivot in that last column, right? There's already 4 rows, 4 pivots, even within the coefficient matrix. So when I add that right-hand side, that last column, there can't be a pivot there. So since the coefficient matrix has a pivot in each row, the augmented matrix cannot have any pivots in the last column. Right, and that's sort of, I hope, I hope it's clear from just comparing that coefficient matrix and the augmented matrix, there's just no other rows where the pivots could be, right? If there were a pivot in that last column, well, that would mean that I couldn't have had 4 in the coefficient part, right? And so that's enough for us to understand that this must be consistent. Okay, so thus, this system is consistent. And how do I know that? I know that because of a theorem we talked about in class, that a system of equations is consistent if and only if the augmented matrix does not have a pivot in that last column. In this setup, we know that there cannot be a pivot in that last column. So this is a consistent system. Now, I think that's actually the harder part. Once I know that this is a consistent system, I can quickly now tell whether there's one solution or infinitely many solutions by thinking about how many free variables there are. Now, in these pictures, we can see that because there are 4 pivot columns, there must be 3 non-pivot columns. So since there are 7 columns total, and 4 pivot columns, there must be 3 non-pivot columns. Meaning 3 free variables. Well, if I have a consistent system that has free variables, then we know that those free variables will provide us infinitely many solutions. So thus, this has infinitely many solutions. And that's kind of cool. Even though there were no values given anywhere in this question, we were able to see that by just considering where the pivots are, we are able to deduce that there couldn't be a pivot in that rightmost column of the augmented matrix. So the system was solvable for sure. And because there are too many columns, essentially, we know there have to be free variables, so they're infinitely many. All right. I hope you thought this was an interesting exercise. I hope you sort of think about the concepts a little more deeply. If there are any questions, please let me know.